Yo guys, it's 9 a.m. in the morning. I came up here in the workshop and I'm waiting for the students to come. So basically in this video we'll build a robotic arm with Arduino and some servos. Actually, the students will build it and I'll just help them. Yeah, probably. And also make this video to you as a tutorial. I'll tell you everything about how we are building the circuits, the coding stuff, the 3D designing, and that's it. So everything used in this video, like the codes, 3D parts, everything is available on below in the description. So let's go. First of all, on some clips of the video, microphone didn't work well, so we used AI enhancer programs to enhance our voices. It's not bad, but anyways, we apologize for that. As a beginning, we 3D design the parts of our project and then print them out. As soon as the 3D printing was finished, we noticed some technical errors we had made in the design and set about correcting them. But for you, no worries, we fixed all the errors on the design as well, so you can just print and start using them. Then we started making joint 1. On one side, the arm of joint 1 would be held to the base, and on the other, the servo would move it. However, because the servo couldn't reach the hole it needed to fit into, we had to print another part. As soon as the 3D printing was completed, we placed the servo on the right wing of joint 1. However, when we sent some test code to the Arduino, we noticed the arm was shaking as it moved, so we made some changes. We removed this bottom part of servo and this part from the right wing. But you don't have to worry about this, because we already fixed on the design, so you're good. Then we prepared and placed a bolt on the right wing to make the joint more solid. And finally glued the servo on joint 1. We made a test code with the joysticks, and as you can see, finally it started moving without shaking. So now we can move on to the base. Find the center of the base at the bottom and place the servo head there. You can do this using either screws or adhesive, but I recommend screwing it in for added strength. Then screw the servo to the base. Next, we need to drill the base through the center hole of the servo head. This is where the screw that will secure the servo to the head will go. We then sent a code to test the base and noticed that the base was shaking while rotating due to the gap between the base and the joint. So we decided to print an extra ring-shaped part. After printing the part, we removed the base and joint 1, placed the ring in between, and then reassembled everything. And as you can see, it works better now.
Now let's build the rest of the arm.
Now we move on to joint 2. In joint 2, we first place the servo motor on the left wing of joint 1, and we also secure it with a bolt from the right wing. And at the end of joint 2, we fasten the right wing and left wing together with bolts. On this note, guys, after adding the last part of the arm, now we're gonna test this servo if it works properly, and then all the servos simultaneously, and finish the project. Let's measure the length of this screw that remains outside of the part. It's 10 millimeters, and we're gonna cut this screw 10 millimeters so it will fit to our part. Let's go. Safety first. Good. And now, guys, I think it's done. So, two joysticks, one of them controls the base and this servo, and the other one, this servo on top. You did a great job. Yes, thank you. Your friends.
Thank you very much.
A few moments later.
Alright, guys, so a problem occurred here. This servo is too much loaded, and you just play with the joysticks, and so as you can see it goes down, but when it comes to going up it struggles. Yeah. So what we're gonna do, we're gonna change the servo with this Metal Gear MG90S servo. So it's stronger, and I think it will solve our problem. Let's go.
Oh, yeah.
And now, as you can see, we connected the metallic gear servo to our Arduino, and we're gonna test it. There is the test code that we wrote, and yeah, let's plug it in the computer. Now, as you can see, it works pretty well. And now it's time to put that servo in this socket here, so we can have our arm moving again. Ooh.
Alright guys, so we replaced the servo with the metallic gear one, and now it's more stable, and also we get a smoother movement. Yo guys, Albanian engineering, you're welcome.
A few moments later.
When I said Albanian engineering, guys, I wasn't joking. So it's actually working and like a little beast. Oh. Now we are moving on to making the final part of the arm, the arm's gripper. Instead of sitting around for hours designing it, we found a ready-made design and integrated it into our project. I found this arm's gripper from this guy on Thingiverse. Gear down for what? Thank you, bro. And now we're gonna print it. So we got a problem here. This fork, or whatever you call it, this piece doesn't fit properly on this part. So what we're gonna do, we're gonna just smaller a little bit this piece. I think just 1 millimeter is enough, and print it. So the parts are ready. Now just let's try if it fits properly on this part. I won't bother to redesign. I won't bother redesign it, so I'll just cut this part off and glue the fork to its place. So I'm gonna glue it, and I think it's gonna be right. Alright guys, so now we're gonna put the pieces together. So it's all done. Now let's just glue these pieces. Right guys, so the hand is all done. It works properly, and now what it remains just to assemble it with the arm and finish the project. So we tried to assemble these two parts, but we realized that this part is too long and it disrupts the center of the gravity, and we're gonna cut this half and then place this fork just like this. So let's do it. Perfection. Alright guys, so we're almost dead. I mean, our battery is almost gonna die, as you can see. We gave up on using the wireless module on controlling the project and decided to make a manual controller. Now, as you can see, Elias is working on the potentiometer controller. We tried to make it with joysticks as well, but then find out that the joysticks are not appropriate components for this. And yeah, we're making with the potentiometers. After completing the test circuit, we wrote a short code and tested whether the potentiometers and the other parts of the arm were working properly. So, as you can see guys, here we have 4 potentiometers. One of them is for the base, for tuning the right and left. The other one is for the edge, so the fork, to grab different stuff. The second joint and the fourth joint. As you can see, it works all very fine. Now let's just get rid of these cables and make the PCB. When we moved on to PCB design, we decided to make the Arduino and control panel together and to keep the board that distributes power and signals to the servos inside the base along with the batteries. After completing the circuit design phase, we designed a box for the control panel And now we are printing it on 3D printer. Alright guys, so after 5 hours of waiting, finally we have the case. And now let's assemble all the electronics and place the controller inside the case. When we placed the control panel circuit into the box, we realized that the solder board we chose was larger than the box itself. And as a solution to this problem, we cut the board smaller. I got the wire. Now that the control panel is ready, we can connect it with the arm's base. But before doing that, we printed the last part of the project, so the bottom part of the base. And after this, we will finish the project.
Years later.
What the hell is going on?
I was genuinely tired of breathing in the solder fumes and designing circuits for hours to finish the project, and just wanted to take some rest. Here we wrap the wires with heat shrink tubing to make the project look more aesthetic and more durable, and then just place the batteries on base, and the project is done, finally.